AMC 8, 2015. Number 1. How many square yards of carpet are required to cover a rectangular floor that is 12 feet long and 9 feet wide? There are 3 feet in a yard. So the rectangular floor is the 12 feet long. 12 feet, we need to convert to the yard, so divided by 3. That's the length. The width is the 9 divided by 3. The area is the 4 times 3. That's the 12. So the answer is A. Number 2, point O is the center of the regular octagon ABCDEFGH, and X is the midpoint of the side AB. What fraction of the area of the octagon is shaded? Regular octagon, that means that all the side lengths are equal. We connect vertices. Now, the octagon divided into the 8 part, total is the 8. And the shaded area is the 1, 2, 3.5. So that's the 3.5. X is the midpoint, so OXB is the half of the triangle. So simplify this one, 7 times 2, numerator, denominator. That's the 7/16. That's the answer D. Number 3, Jack and Jill are going swimming at a pool that is 1 mile from their house. They leave home simultaneously. Jill rides her bicycle to the pool at a constant speed of 10 miles per hour. Jack walks to the pool at a constant speed of 4 miles per hour. How many minutes before Jack does Jill arrive? So from the home to the swimming pool, that's the total, the 1 miles. And we know the time equals distance over speed. For the Jill, is the time is the 1 over 10 miles per hour, 1 mile. 10 miles per hour. So that's the 1 over 10 hour. Convert to the minutes times 60. That's the 6 minutes. And the Jack time is the distance is the 1, speed is the 4. That's the hour, 4 miles per hour. So time is the hour. Convert to the minutes, that's the times 60. That's the 15 minutes. So they ask how many minutes before Jack does Jill arrive. Use the 15 minus 6. That's the 9 minutes. That's the answer D. Number 4. The Centerville Middle School chess team consists of 2 boys and 3 girls. A photographer wants to take a picture of the team to appear in the local newspaper. She decides to have them sit in a row with a boy at each end and the 3 girls in the middle. How many such arrangements are possible? So they total have the 5 students. That's the 1, 2, 3, 4, 5. 2 boys must sit at each end. So for the first, the beginning, they have the two choice. The two boy can arrange in the first one. They have the two choice. The last end, just the boy left, we can put in the one. So for the boy, for the girls, the first, the second position, that's the first girl, we have the three choice. So any one of the three girls can sit on here. And also the third place has another two choice, only the two girls left. So we can choose any the girl sit on here, and there are only the one space for the one girl. So the total is the 2 times 3, 6 times 2, 12. So there are 12 arrangements are possible. That's the answer E. Number 5, Billy's basketball team scored the following points over the course of the first 11 games of the season. If his team scores 40 in the 12th game, which of the following statistics will show an increase? So look at the 5 choice. The range, the number 8. Choice A is the range. Range is the largest number minus smallest number. That's the 73 minus 42 is the 31. And after the 12th game, the smallest number is the 40. Range will be the 73 minus 40. That's the 33. So it's the range from 31 to 33. It shows the increase. So the answer can only be the A. Number 6, in triangle ABC, AB equals BC equals 29 and AC equals 42. What is the area of triangle ABC? Triangle, this is an isosceles triangle. So AB equals the ABC. AB equals BC equals 29. And AC equals 42. The area of the triangle ABC. Easy one. For this problem, we use the Heron's formula. That's the Heron's formula. That's the semi-perimeter times S minus the A, S minus B, and S minus C, the square root. So S, it's the semi-perimeter. Perimeter divided by 2. For this problem, it's the 29 times 2 plus 42 divided by 2. That's the 100 divided by 2. That's the 50. That's the semi-perimeter. So area equals square root 50 times 50 minus 29. That's the 21. 50 minus 29, another 21, times 50 minus 42. That's the 8. So 21 square. That's the 21. So 50 times 8, that's the 400. That means the square root 400 is 20. So total is the area is the 420. That's the answer B. So if you don't know Haran's formula, you still can use the Pythagorean theorem. From the B, draw the perpendicular line to BC. Because the isosceles triangle, the altitude also the median, so this two part is the equal 21. Use the Pythagorean theorem, can find the height and use the 1/2 times base times height. But use Haran's formula, pretty easy. Number 7, each of 2 boxes contains 3 chips numbered 1, 2, 3. A chip is drawn randomly from each box and the number on the 2 chips are multiplied. What is the probability that their product is even? The probability is the expected overall. So what's the all event? All event, the first has the 3, the 1, 2, 3. So that's the 3, the choice. Second, still 3. That's the total events. That's the 9. What's the product is the even. If first the number is the 1, only the second is the 2. That's the even. If the first, the chips shows the 2, and the second chip can be the 1, 2, 3. The product all even, so that's the 3 case. If the first, the box choose the number 3, the only number 2, the second is the number 2, give us the even product. So total is the 5 cases. So the probability product is even is the 5/9. That's the answer E. Number 8. What is the smallest whole number larger than the perimeter of any triangle with a side of length 5 and a side of length 19? This is the triangle. Now we draw the triangle. We have the 3 lengths. One is the 5, one side 19. Last one. And third side is the x. Triangle inequality tell us I need the sum of the 2 sides must greater than third size. So that's the x less than the 24. The perimeter of the triangle, so equal to 5 plus the 19 plus the x, and the x less than 24. That means that's the 24. Less than 24, that's the p less than 48. So the perimeter less than the 48, and they ask smallest whole number larger than perimeter of any triangle with the side length 519. So 48, that's the smallest whole number larger than perimeter, because perimeter less than 48. So the number 8 answer is D. Number 9. On the first day of work, Janabel sold 1 widget. On day 2, she sold 3 widgets. On day 3, she sold 5 widgets. On day 3, she sold 5 widgets, and on each succeeding day, she sold 2 more widgets than she had sold on the previous day. How many widgets in total had Janabel sold after working 20 days? So first day, he sold the 1. Second day, he sold the 3. and 5 and 7 continue on. What's the 20th day he sold? This is arithmetic sequence. Common difference is the 2. What's the A20? 20th term. We use the formula. So the general term is the A1 plus the n minus 1 times common difference. For this problem, the first term is 1 plus the 20th term, use the 20 minus 1. Common difference, that's the 2. So this is the any adjacent 2 number has the difference 2. So that's equal to 39. So the 20th term is the 39. And they ask how many widgets in total had Janabel sold after working 20 days. So they ask the sum of the 20 days he sold the widgets. So the sum of the arithmetic sequence sum equals the first number plus the last number times number of number divided by 2. And the 20 terms sum, that's the first term, is the 1. The last term, 20th term, is the 39. Number of the number is the 20 divided by 2. So cancel 2, that's the 10. So that's the 400. So the total is the 400 widgets sold. The answer is D. Number 10. How many integers between 1,000 and 9,999 have 4 distinct digits? So we have the 4 digits, 1, 2, 3, 4. They ask distinct digits. For the first digit, from the 0 to 9, we only have the 9 choice. 0 cannot be in the first digit. For the second digit, 10 digits already use the 1. I still have the 9 choice for the second digit. For the third digit, that leave us the 8 digits to choose. And the last one have the 7 digit to choose. 9 times 9, that's the 81. 7 times 8, that's the 56. One's digit must be 6. So the only B, that's our answer. The one's digit is the 6. So the number 10 answer is B. Number 11. In the small country of Mathland, all automobile license plates have 4 symbols. The first must be a vowel. The second and the third must be 2 different letters among the 21 non-vowels. And the fourth must be a digit 0 through 9. If the symbols are chosen at random subject to these conditions, what is the probability that the plate will read AMC8? The probability is the expected event. Over the all events. Expected just the AMC8, that's the one case. What's the all events? That's the license plate, that's the 4 symbol. So 1, 2, 3, 4. The first one must be a vowel. So the total vowel is the 5. So we have the 5 choice from the A, E, I, O, U. We can choose the one. The second and the third are two different letters among the 21 non-vowels. So the second, we have the 21 letters to choose, and the third one only 20 because that's the different letters. The last the place we can choose from the 10 digits 0 through the 9. That's the 10 choice. The total is, now we use the 20 times 500 times the 10. That's the 1,000 times 21. So the total events, that's the 21,000. The all events is the 21,000. So the probability is the 1 over 21,000. That's the answer B. Number 12. How many pairs of parallel edges, such as AB and GH, or the EH and FG, does a cube have? Now that's the cube. Each cube from like the AB has the 3 parallel lines, EF, HG, and DC, 3 pairs. So one edge is parallel to the 3 other edges. So AB parallel to EF, HG, DC. Total of the cube has the 12 edges. So total 12 times 3, that's the total. But each pair of the edges is counted twice. We count the AB parallel the EF. That's the one pair of the AB. We also counted for the EF. Still have the EF parallel AB. That's the 3 parallel lines. So each pair of the parallel edges we count twice. So we divide it by 2. So cancel 2. That's the 6. 3 times 6, that's the 18. So the answer is C. Number 13. How many subsets of 2 elements can be removed from the set so that the mean of the 9 remaining number is the 6? So the 11 number sum is the 1 plus 11 times number of the number 11 divided by 2. That's the 66. That's the arithmetic sequence sum equals the first number plus the last number times number of number divided by 2. And then the remaining 9 numbers, the average is 6. That means sum is 6 times 9. That's the 54. The original and the remaining the set, that means that their difference is the 12. So we can only remove the 12. The 2 numbers, the sum is 12. That will be the 1, 11, that's the 12, 2, 10, 3 and 9, 4 and 8, 5 and 7. The 6, no pair numbers, so total is the 1, 2, 3, 4, 5, the subset of the 2 elements can be removed. So the answer is D. Number 14. Which of the following integers cannot be written as the sum of 4 consecutive odd integers? We know odd integer general term is the 2n minus 1. So if the odd integer is the 2n minus 1, second will plus 2. That's the 2n plus 1. 2n plus the 3. And 2n plus 5. That's the 4 consecutive odd integer. We add them together. That's the 1, 2, 3, 4. That's the 8n plus the 3 plus 5, 8. Factor out 8. That's the 8 times n plus 1. So the sum must be the multiple of the 8. In the 5 choice, first one is the multiple of the 8. 40 multiple of the 8, 72 and 200. Only the D, not the multiple of the 8. So the answer is the D. Number 15. At Euler Middle School, 198 students voted on 2 issues in the school referendum with the following results. 149 voted in favor of the first issue, and 119 voted in favor of the second issue. If there are exactly 29 students who voted against both issues, how many students voted in favor of the both issue? Now we draw the one diagram. So the total student is the 198. So the first issue, total 149 students voted in favor of the first issue, and the 119 voted for the second issue. Voted for both the issue is X student. So the only vote for the issue is the 149 minus X. Only in favor of the second issue student, that's the 119 minus X. And also 29 students against both. So the 198, that's the total student, equal to the number of the student just in favor of the first issue, plus the X student who in favor of both issue, plus 119 minus X students who in favor of the second issue, and plus 29 against both. So negative X plus X, that's the 0. We can cancel positive negative X. Negative X move to equation left side, give us positive X. The right side is the 149 plus the 119 plus the 29 minus 198. 297 minus 198. That's equal to 99. So there are 99 students voted in favor of both issue. That's the answer D. Number 16. In the middle school mentoring program, a number of 6th graders are paired with a 9th grade student as a buddy. No 9th grader is assigned more than one 6th grade buddy. If the 1/3 of all 9th graders are paired with the 2/5 of all the 6th graders, What fraction of the total number of the 6th and the 9th graders have a body? Let X is the total of the 6th graders and Y is the 9th graders, the number of the 9th grader. So 1/3 of the 9th, that means the 1/3 of the Y equal to, they paired with the 2/5 of all the 6th grader. That means the 1/3 of the Y, that's the number of the 9th grader, has the body, equal to 2/5 of the X, that's the 6th students. The grade 6 students has the body. So that means the Y equal to cross multiplying 6/5X. Now, what is the fraction of the total number? So, the body, the student who has the body, grade 6, that's the 2/5 X, plus grade 9, that's the 1/3 of the Y, that's the total number of the students have the body. And the total is the X plus Y. X is the 6th grader, Y is the 9th grader. And because the 2/5 of X equal to the 1/3 of the Y, we can rewrite as the 5/2X plus the 2/5X. Because the 1/3 of the Y equals the 2/5 of X. So the total X plus Y equal to, from that equation, we get the Y equal to 6/5X. Now we have the numerator is the 4/5X. Denominator, that's the 6/6, 5/5X, that's the 11/5X. Now we cancel X. So we can use the inside times inside to the denominator, 5 times 11. Outside times outside to be the numerator. That's the 5 times 4. Cancel 5 equal to 4/11. So the fraction of the total number of 6th and 9th graders have a body is the 4/11. That's answer B. Number 17. Jeremy's father drives him to school in rush hour traffic in 20 minutes. One day, there is no traffic, so his father can drive him 18 miles per hour faster and get him to school in 12 minutes. How far in miles is it to school? We know distance equals the speed times time. From the home to school, the distance we don't know. We still use the D. And the speed, we use the X. Speed, that's the rush hour speed times time. Time is the 20 minutes. Speed is miles per hour unit, so we need to convert the 20 minutes to the hour divided by the 60. So that's the 1/3 of the speed equals the distance. And no traffic distance still need the speed. So no traffic speed is the 18 miles per hour faster. So speed is the s times 18. Use the 12 minutes. Rewrite as the hour, 12 over the 60. So that's the s plus the 18 times the 1/5. Now we rewrite the first equation to do the speed equals the 3 times the distance. We write here speed. From this equation, we get speed equals the 3 times distance. From the second one, we get speed equal to 5d minus 18. So now from these two equations, we use the equation 2 minus equation 1. That's the 2 distance minus 18 equals 0. And the distance equals the 9. So the answer is the D. Number 18. An arithmetic sequence is a sequence in which each term after the first is obtained by adding a constant to the previous term. For example, 2, 5, 8, 11, 14 is an arithmetic sequence with 5 terms in which the first term is 2 and the constant added is 3. Each row and each column in the 5 by 5 array is an arithmetic sequence with 5 terms. What is the value of x? So each row and each column is arithmetic sequence. So arithmetic sequence general term n equal to the first number plus the n minus 1 times common difference. So for the first row, 25, that's the fifth number, equals first number is the 1 plus the n is the 5. 5 minus 1 times common difference. That's the 1 plus the 4d. So 4d equals 25 minus 1. That's the 24. So d equals the 6. D equals 6. The second number will be the 7, 13, 19, and 25. Same thing for the column. For this, the first column, that's the 17. That's the fifth number, equals the 1 plus the 5 minus 1. That's the 4d. So 4d equal to 7 minus 1, 16. D equals the 4. So 1 plus 4, that's the 5, plus 4, 9, plus 4, 13, plus 4, 17. The last column, still the arithmetic sequence. So 81 equals the first number, 25, plus 5 minus 1, that's the 4d. So 4d equal to 81 minus 25, that's the 56. So D equal to the 14. D is 14. That means the second number, 25 plus 14, that's the 39. 39 plus 14, that's the 53, plus the 14, 67, and then 81. Now we do the third row. The x in the third row, we can do the third row. So 53, the an equals a1, that's the 9, because we do this row, third row. 9 plus 5 minus 1, that's the 4 times common difference. So the 4D equal to the 44. D equals 11. D equals 11. So in the third row, second number is the 20. X equals 20 plus 11, 31. So, and the next number plus 11, 42 plus 11, 53. So the value of the x is 31. That's the B. Number 19. A triangle with vertices at A equals 1, 3, B 1, 5, 1, and C 4, 4 is plotted on the 6 by 5 grid. What fraction of the grid is covered by the triangle? Now we draw this the rectangle. The rectangle, the area of the ABC, we use area of the rectangle minus 3 the triangle, the part 1, part 2, part 3. Use the rectangle area minus the triangle 1, triangle 3, triangle 2 area. And then we can get the triangle ABC, the area. So area of the ABC equal to 4 by 3. So 3 times 4. This side is the 4. The width is the 3. That's the 12. Minus the 1. The part 1, that's the right triangle. That's the 1 over 2 times base is the 3. Height is the 1. Minus part 2, the 1 over 2. Base, that's the 1. Height, that's the 3. Minus part 3, the base is the 4, 1 over 2 times base is the 4, height is the 2. Now calculate 12 minus 3 over 2 minus 3 over 2 minus 4 equal to 12 minus, we add these 3 parts together. That's the 6 over 2. That's the 3. 3 plus 4, 7. 12 minus 7. That's the 5. So the area of the ABC is the 5. And the grade is the total, is the 1, 2, 3, 4, 5, 6. 6 by the 1, 2, 3, 4, 5. 6 by 5. Total is the 30. So 5 over expected is the triangle over total. That's the 30. So that's the 1, 6. So the answer is A. Number 20. Ralph went to the store and bought 12 pairs of socks for a total of $24. Some of the socks he bought cost $1 a pair. Some of the socks he bought cost $3 a pair, and some of the socks he bought cost $4 a pair. If he bought at least one pair each type, how many pairs of $1 socks did Ralph buy? Let X, Y, Z be the number of pairs of the $1 and $3 and $4 socks. So that's the X plus Y plus Z. That's he total bought. It's the 12. And also, total cost him the $24. That means the X, 1X plus 3Y plus the 4Z equal to 24. Now from the equation the 1, Z equal to 12 minus X minus Y. So plug this equation into the second equation. That will be X plus the 3Y plus 48 minus 4X minus 4Y equal to 24. Now we let the 3X, so move all the constant to the left side. 48 minus 24 equal to, that's the 3X plus Y. So 24 equal to 3X plus Y. 24 equals 3X plus Y. So 3X is the multiple of the 3, and the 24, that's still multiple of the 3. That's the 3 times 8. So the Y must be the multiple of the 3, because multiple plus multiple still the multiple. So the Y at least is the 3 multiple. So if Y equals 3, then the X must be, if the Y equals 3, X will be the 7, because the 3 times 7, 21 plus 3, and also the Z equals the 3 plus 7, that's the X plus Y 10. Z must be the 2, so it satisfies both the equation X plus Y plus Z equals 12. X plus 3Y plus 4Z equals 24. So our problem is, how many pairs of $1 socks did Ralph buy? He bought 7. That's the choice D. Number 21. In the given figure, hexagon ABCDEF is equiangular. ABJI and FEHG are squares with the area 18 and 32 respectively. Triangle JBK is equilateral and FE equal to BC. What is the area of the triangle KBC? ABJI, that's the square. Area is the 18. So the side length is the square root 18. That's the 3 root 2. So the 3 root 2. JBK is the equilateral triangle. So BK, that's the same thing, 3 square root 2. And also GFE HG area is the 32. So EF is square the 32. That's the 4 root 2. Root 32 equals the 2 times 16. 16 is the 4 square, so that's the 4 root 2. Because the FE equals BC, so BC is the 4 root 2. So we need to find what's the angle KBC. If the KBC is the right angle, that will be easier to find it, but we will see what's the angle. Looks like the right triangle. JKB, that's the equilateral triangle. The one angle is the 60. JBA is the 90. Well, how about ABC? Angle ABC, we know the sum of the interior angles of the polygon equal to the n minus 2 times 180. So this is the n is the 6 because that's the hexagon. So 6 minus 2 times 180. That's the 4 times 180. That's the 720. That's the sum of the hexagon. Because the hexagon is the equiangular, so we use the 720 divided by 6. That's the 120 degree. That's the one angle. Each angle equals 120. So ABC is the 120. So the angle KBC. The angle KBC equal to 360, all overall is the 360, minus 2 right angle, that's the 180, minus 60, minus another 120. So that's the angle KBC equals 360 minus 60 minus angle ABJ, that's the 90, minus ABC, that's the 120, equal to the 90 degree. So the KBC is the 90. Now we look at the KBC is the 90. So the area of the KBC equal to base is the BK, that's the 3 root 2. So 1 over 2 times base, 3 root 2 times height, 4 root 2. So that's the 12. So the answer is C, 12. Number 22. On June 1, a group of students is standing in rows with 15 students in each row. On June 2, the same group is standing with all of the students in one long row. On June 3, the same group is standing with just the one student in each row. On June 4th, the same group is standing with the 6 students in each row. This process continues through the June 12 with a different number of students per row each day. However, on June 13, they cannot find a new way of organizing the students. What is the smallest possible number of students in the group? On June 1, 15 students in each row. So the number of the students must be the multiple of the 15. On June 2nd, all the students in the one long row, so that's all the students, still the multiple of the 15. On June 3rd, the same group, just one student in each row, so one row is the one student. On June 4th, that's each row 6 students. So each row 6 students. So the number of the students must be the 15 and the 6, multiple of the 15 and the 6, and till the June 12th. On the June 13th, they cannot find a new way to organize the students. That means the number of the student is the LCM of the 15 and the 6. That means the 15 is the 3 times 5. 6 is the 2 times 3. Total is the 30. Because they can arrange the 12 days, that means that they have the 12 factor. 30 has the factor 1 times 30, 2 times 15, 3 times 10, 5 times 6. Just the 8 factors, so not our answer. The next multiple is the 60. So 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. So that's the total is the 12 factors. So the smallest possible number of the students is the 60. That's the answer C. Number 23. Tom has 12 slips of paper, which he wants to put into 5 cups labeled A, B, C, D, E. He wants the sum of the numbers on the slips in each cup to be an integer. Furthermore, he wants the 5 integers to be consecutive and increasing from A to E. The numbers on the papers are and 222, 2.5, 2.5, 3, 3, 3, 3, 3.5, 4, and 4.5. If a slip with 2 goes into cup E and a slip with 3 goes into cup B, then the slip with 3.5 must go into what cup? So let's draw the 5 cups. The 1, 2, 3, 4, 5. That's the A, B, C, D, and E. And also slip with 2 goes into the cup E. So here has the 1, 2. And also the slip with 3 goes into cup B. B has the 1, 3. Now they ask 3.5 must go into what cup? So all the numbers, add them together. 2 plus 2 plus 2. That's the sum equal to 35. So that's the 35. And also they told us that he wants the 5 integer to be consecutive and then increasing from A to E. So from A to E, the numbers, sum of integer in every cup is the integer. Sum of them equals 35 and they are consecutive. So 5 numbers consecutive the number, sum is the 35. The mean is 35 divided by 5, that's the 7. For the arithmetic sequence, or another way, for the consecutive numbers, the mean equals median. So 5 number median, that's the C. So 7 is the C. Now we get D is the 8, E is the 9, and 6. So A is the 5. So A is the 5. We only can put the 2 and the 3, put in the cup A. So we put the 1, 2, 1, 3. So we already have the 2, 2. Use the 2, 3, okay? So 2 plus 3 is the 5, and 6 is the 3 plus 3. So we put another 3. So we cross another 3. And that's the 6. For the C, that's the 7. We can put the 2.5. 2.5, that's the 5, and 1, 2. So add together is the 7. So 1, 2, 2, 2.5. It's not need the 7. We can put the 3 and the 4. So that's the 9. 2, 3, 4 on the E. And for the D, I cross the 3 and the 4. Now for the D, only leave us the 3.5 and 4.5. That's the sum of the D. Now we used all the slips. So the question is, the slip with the 3.5 must go into what cup? 3.5 is here, go to the cup D. So for the number 23, the answer is choice D. Number 24, a baseball league consists of 2 4-team divisions. Each team plays every other team in its division N games. Each team plays every team in the other division M games with N greater than 2M and M greater than 4. Each team plays a 76 game schedule. How many games does a team play within its own division? Let's say the 2 division, each division has the 4 teams. If division 1 has the A, B, C, D, and the division 2 is the E, F, G, H. So each team play the every other team in its division N games. Let's for example, the AB will play the N times. So AC N times, AD N times. So that means the A play inside the division will be the 3N. The total game will be 3 times N. And play the other team in the other division. So that will be have the 4 games. Each the team with the M times, that will be the 4 M's. A play with the E, M times F, M times G, M times H, M times A. Total play 3N plus the 4M. Total game is the 76. That means the 3N plus the 4M equals 76. We still have the 2 restriction. M greater than 4. And also the N greater than the 2M. That means the N greater than 8. M greater than 4. N must greater than 8. Look at this equation. 4M is multiple of the 4. 76 still the multiple of the 4. 76 is multiple of the 4. That's the 4 times 19. 3N must be the multiple of the 4 because multiple plus multiple, that's the multiple. So 3N must be the multiple of the 4. So that means the N must be the multiple of the 4. And also N greater than 8, that's the 12. So if N is the 12, that means the 3 times 12 plus the 4M equal to 76. M equal to 10. That's the first pair, M and N. That's the 12 and 10. So M greater than 4. That's okay. But the N greater than the 2M and not greater than the 10. So this pair not working because the N not greater than 2M. If N is the 16, that will be the 3 times 16 plus the 4M equal to 76. That's the M equal to 7. M equal to 7 and N equal to 16. So M greater than 4, it's okay. N greater than the 2M, 2 times M 14. So the N greater than 14. So this pair is good. 16 and 7. And still we will see if we have the other pairs. Another is the 20 times 3. 20 is multiple of the 4 plus the 4M equals 76. And then M equal to 4. That's not satisfy the restriction. M greater than 4. So this not working. 20 and 4 is the integer but not working. The M equals the 7 and N equal to 16 is our answer. And now they ask how many games does a team play within its own division. So within the own division is the 3N. That's the 3 times 16. That's the 48. That's the choice B. Number 25. 1-inch squares are cut from the corners of this 5-inch square. What is the area in square inches of the largest square that can be fitted into a remaining space? So the square like this is the largest the square we can do. Cut off is the 1 by 1. So cut off the 1, that's the 1, 1, 1, 1. So in the middle will be the middle is the 3. And also this side still the 3. So easy way to calculate this area, we find the area of the square. So area of the square in the smaller one inside the largest square is the 3 times 3 plus the full triangle area for the one triangle base times height. So 1 over 2 times base is the 3, height is here. So height equals to the 1. So 3 times 1 divided by 2. They are exactly the identical triangle. So we times 4. That's equal to 9 plus the cancel 2. That's the 6 equal to the 15. The answer is C.